the 0 of the quadratic polynomial R. So let's recap the idea of 0, then we'll look at the option. So what is a 0? 0 is the input value, which when put in place of the independent variable, the entire expression gives an output of 0, right? Minus 3 plus 3 is 0. If I put any other value in this case, I won't get a output of a 0. So 0 as an input value can be a negative, positive, or a 0 value itself. It need not be just 0. So if I put any value which makes output to be 0, it's called the 0 of the polynomial. Here the question is, can they be positive? Can they be negative? Can one be positive, one be negative? Can both be equal? See, use your common sense. We have a polynomial, right, which is entirely made up of positive set of values. The question is, can they be positive altogether? Clearly not. Why? If I put a positive value, will I get a 0? Obviously not. Right? Should both be negative? Yes, it can be. One being positive and one being negative? No, not a good option. Can both be equal? See, between option B and D, it's clear that option B is the answer. We are very sure that both have to be negative. But I would like to explore the option of both being equal. Say it was equal. Some question somewhere you might get such a tricky scenario. So I would like to explain why is that they are not equal. Okay, how can we explain with our knowledge without finding the actual values? You can find the actual zeros of it, splitting the middle term, formula method, so on and so forth, trial and error, so on and so forth. But I would like to discuss how can we do this technically. So we know that alpha plus beta is minus p by a. I'm just writing what is obvious. So this entire thing will be equal to minus 99 by 1. And we have alpha into beta, which is c by a, which is equal to 127 by 1. Now with this set of information, can we figure out if alpha and beta are equal? What should we use? Well, you should be using both actually, but with this we can just tell that they are not equal. Why? See, it's clear that alpha is not equal to beta. The reason being, as alpha beta, the product is not a perfect square. Okay, since clearly we don't have alpha, not being equal to beta, alpha beta not being a square of some number, so alpha is clearly not equal to beta. So the answer is option B. Okay, again, it will be useful at some point of time to understand that if alpha and beta were a perfect square like 64, or what I mean is perfect square, it is example, it's like 64 or 121 or what else? You guys know, big numbers, small or big, the squares of numbers, right? So if we have such a scenario, then yeah, there is a small possibility, and it will confirm it with the help of alpha and beta. So if it was a perfect square like 64, so alpha plus beta would have been what? Minus 16. Okay, something like that. So it would be very obvious to you guys. So in this particular scenario, it's very clear that alpha and beta are not equal, as this is not a perfect square. So we can tell that no, option D is wrong. Again, it's only for your understanding. It's not to be written in your exam, especially for an MCQ question. Yes, if anything related to such a question, and if it's not an MCQ question, then yeah, such an explanation would be required. Okay, so you can pause and have a look. And yes, think over this question. Don't just brush it through. Don't just write it through. Pause and think over. Try to just understand. Give yourself some examples.